The F-22, a crucial member of the Global Strike Task Force, is built to quickly and far away project air dominance and destroy adversaries that try to bar our country's Air Force, Army, Navy and Marine Corps from a targeted area. No existing or future fighter aircraft can compete with the F-22. Here is all we know about the new upgraded F-22 Raptor that will leave the world astounded. Although the F-22 Raptor stealth fighter is the best air superiority aircraft ever, if not the best tool for safeguarding American interests in Asia, the United States Department of Defense plans to upgrade the F-22 Raptor fleet of the United States Air Force in what could be the stealth fighter's most important upgrade ever. It is unclear what upgrades Lockheed will incorporate in the F-22. Improvements to the Raptor stealth coating, as well as updates to the digital interface are possible. If all alternatives are used, the project is projected to take a decade to complete. Work is expected to be completed by October 31st, 2031, according to the Department of Defense. Though the F-22 is unquestionably one of the best fighters in the world, it may be surpassed in the near future by the 6th-generation aircraft, some of which had already flown. However, until the 6th-generation fighters are widely available, Americans' flying branch will have to rely on their Raptors. The United States Air Force has begun work on integrating an infrared search and track sensor, or IRST, into its stealthy F-22 Raptor air supremacy fighter. The IRST, a sensor that provides a significant capability to detect and track other aircrafts at long ranges, including stealthy ones, that is completely passive and immune to electronic warfare, was originally planned for the Advanced Tactical Fighter (ATF) program, but it was ultimately dropped on coast grounds. At the very least, the service is considering how to reintroduce the capability into the jet. The Raptor carries 6 AIM-120 and AMRAAMs and 2 AIM-9 Sidewinders in its air-to-air configuration. Surface-to-air missiles are an important capability of the F-22. The aircraft can carry two 1,000-pound GBU-32 Joint Direct Attack munitions internally in the air-to-ground configuration and will rely on onboard avionics for navigation and weapons delivery support. With the inclusion of an updated radar and up to 8 small-diameter bombs, the air-to-ground capability will be enhanced in the future. In the air-to-ground configurations, the Raptor will also carry 2 AIM-120s and 2 AIM-9s. The F-22 engines have more thrust than any other fighter engine currently in use. The F-22 can cruise at supersonic airspeeds greater than 1.5 Mach without using afterburners, thanks to its streamlined aerodynamic design and increased performance, a feature known as supercruise. The qualities of the F-22 create a synergistic effect that ensures that the F-22's lethality against any advanced air threat. Surface-to-air missile engagement envelops are substantially reduced by the combination of stealth, integrated avionics, and supercruise, and opponent capabilities to track and engage the F-22 are greatly reduced. In a tactical situation, the combination of limited observability with supercruise emphasizes the benefit of surprise. The aircraft is 18.9 meters in length, 5.1 meters in height, and 13.6 meters in wingspan. It has a wavelength range of over 1600 nanometers. By weight, the F-22 is made up of 39% titanium, 24% composite, 16% aluminum, and 1% thermoplastic. Titanium is employed for its high strength-to-weight ratio in high-stress regions such as the bulkhead, as well as its heat-resistant properties in the aircraft's hot parts. The fuselage frame, doors, intermediate spars on the wings, and honeycomb sandwich construction skin panels are all made of carbon fibers composites. According to the F-22 Program Office, funding for other sectors not mentioned above may be considered. As previously stated, the initial F-22 was to be equipped with an advanced IRST at a time when such technology was uncommon in Western fighter aircrafts. The pre-production F-22 Raptor, on the other hand, lacked an IRST. The sensor was one of a number of capabilities that were cut early in development, including side-looking airborne radar SLR arrays that would have been mounted on the sides of the jet's diamond-shaped nose. It is difficult to imagine how an IRST sensor could have been fitted in today's F-22. The Raptor's carefully controlled low observable features might be disrupted if an additional pod was added. Internal installation of the sensor is a possibility, but it would likely necessitate a considerable rebuild that would have to take into account the influence of the change on the aircraft's total radar signature. future. Then there is the matter of whether the IRST's originally designated interior space, as well as enough cooling, is still available, given that a series of in-service improvements have put these locations in high demand. In 2017, Ken Merchant, then Vice President of Lockheed Martin's F-22 program, told Air Force magazine that, "We don't just have the real estate to integrate an internal IRST in the plane, at least not in a configuration comparable to the F-35's electro-optical targeting system. One possibility is to incorporate IRST-like capabilities into the F-22's current sensors, the AN/ANR-56 Missile Launch Detection System, or MLD. This technology now enables a 360-degree detection of aerial and surface-launched guided missiles threats to Raptor pilot. The MLD system, which is mounted on the aircraft's skin and includes 6 sensors hidden by the low observable windows, is made up of a network of optical components and assemblies. The AN/AAR-56 is a little-known system on the F-22. Its specific capabilities are unknown. However, it is likely to have some latent austere IRST-like capabilities. But the system is well established, and additional components based on cutting-edge technology might potentially add a more comprehensive infrared search and track capability, allowing it to follow numerous aircraft and missile targets beyond visual range. Even with the latest sensor technology, improving the system for longer-range infrared detection and tracking capabilities would result in a different range of capability than what's supplied by a specialized advanced IRST. However, the technology is already present in every Raptor, and it would provide a 360-degree field of coverage that a typical IRST would not be able to deliver. In fact, increasing the MLD on the F-22 would be an excellent complement to a full-fledged IRST. The benefits that a specialized IRST sensor would offer to the F-22 are considerably more clear. The Lockheed Martin AN/AAQ-33 Sniper Advanced Targeting Pod is not carried by the F-22. Unlike many other Air Force tactical jets ATP, although this pod is typically utilized for precise air-to-ground strike and reconnaissance missions, it can also be used for long-range visual air-to-air identification. This is a very valuable skill that allows for high-confidence friend or foe operations over large distances at any time, day or night. The pod does feature a pseudo IRST capability, so it can be used as a poor man's IRST, capable of detecting airplanes across long distances. But yet again, this pales in comparison to the capabilities of a dedicated low-wavelength IRST, designed from ground up for air-to-air combat and equipped with all the necessary back-end processing capacity and software to fully exploit its capabilities, much alone completely integrate them with the aircraft's fighting system. With the current IRST sensor, such as the IRST-21 based one found in the Legion pod, the Raptor pilot would be able to quickly discover and track several targets well beyond visual range. The sensor would also provide additional targeting data, allowing an opponent to be targeted passively without the jet's radar emitting any telltale emissions, which would be particularly beneficial for a stealth fighter. In addition to these types of stealthy engagements, the IRST targeting data could be combined with the data of the F-22's other highly capable sensors, such as its outstanding passive electronic support measure suit, as well as data from other platforms, to improve accuracy and overall situational awareness of the air combat arena. As the Air Force and the United States military in general focuses on more high-end threats presented by China and Russia, adding IRST to its most proficient fighter would provide an additional advantage. Its worth would be realized in the face of a more sophisticated adversary, one that is likely to utilize powerful electronic warfare capabilities, potentially impairing radar and even data link capability. However, the AN/APG-77 ASA radar possesses some of the best low probability of interception LPI capabilities of any radar in the world, making it difficult for hostile sensors to detect it, let alone geolocated. Moreover, the spectrum of aerial threats that an IRST would assist the F-22 in acquiring and engaging plays a role in these high-end situations. A sophisticated IRST can identify objects that radar can't, such as stealthy fighters, drones, bombers, and even cruise missiles, all of which are dangers that could increasingly be confronted in a conflict with Russia or China. IRST, of course, is effective against all non-stealthy varieties as well. Some would argue that mounting an example of the Legion pod to an F-22 is worth it, even if it reduces the ability of one or two Raptors within a fight of numerous jets to conceal from hostile radars. The pod-equipped aircraft could seamlessly share their targeting data with the rest of the flight via the aircraft's proprietary data link, which is extremely difficult to jam, and tactics could be devised to reduce the risk to the IRST-equipped Raptors, while also leveraging the unique information they would provide. As the F-22 seeks to stay relevant in the face of fast-changing peer threats, this type of compromise appears to be in the works in different ways. F-22s can patrol an altitude of up to 60,000 feet, providing them with an incredible line of sight well above the weather and in extremely cold air, which is an ideal for an IRST. With this in mind, finding a way to install one internally, or perhaps using one of the internal AIM-9X rails to selectively deploy an IRST as needed may be a highly worthwhile investment if an external option was deemed unsuitable. The Air Force is reconsidering its plan to equip the F-22 with an IRST, indicating that the sensor could provide even more value to the fighter, even as the service begins to consider a future without the Raptor. Now, assuming the technological challenges can be addressed, the F-22 might very likely see out its career with some types of IRST capability, giving it one of the primary characteristics the Air Force had planned for it from the start. What do you think about the all-new F-22 Raptor? Tell us in the comments section, and stay tuned to our channel to stay updated on such fantastic content. See you all in the following video. Until then, bye bye.